Greetings everyone. Today we're going to talk about bracing. I think you'll like the results of today's test. Some of the results you'll expect, some might not be so intuitive. I think maybe to set the groundwork, we might go over some of the most common theories out there about bracing so we kind of have a context for what we see in the results. I'd say the first theory is if you brace enough or heavily, you'll push all that box radiation down to nothing, stop all those panel resonances, and you're good to go. Another theory says, well, you're really not going to reduce the panel resonances, but you can shift everything up into a frequency range where either your woofer is not operating or where the internal dampening lining on the box can absorb those frequencies. And then, so as a reminder, here's my test box. They're all like this, so I'll be using 3/4 inch plywood from Home Depot, and it's AC Radiata pine plywood. Pretty average. It's not that great quality, but it works. And this is our source driver, and of course this will have a small enclosure bolted to the back, and so in this way the only thing that we're measuring is the sound coming from inside the box. And then of course we will do a near field mic measurement at a side panel in the center and the rear panel in the center. If you want more details about that, go to my first video in this setup, or in this playlist, and that'll go over my test methods. For the bracing, I chose to go with, at first, just some oak trim from Home Depot, and I have not yet got into like window bracing or anything like that. I want to start simple, and you might wonder why. Well, why would I go so simple? Well, any mechanical engineer will understand, this side panel is braced all the way around the outside, or fixed, really rigid, and at least in the low pressure, or I should call it the low frequency simple pressure region, all the deflection is in the center, and if you can stop deflection at the center, you drop that radiation dramatically, and even just a simple brace like this at the center of the panel is something on the order of doubling the panel thickness or more. Okay, so that's why I did that. So let's take a look at those results. So just to kind of give you an idea of how the box looks like, this is the standard box right there. Just a simple 2 dowels, side panels, and front to back. This is the constrained layer dampening braces. Basically they're overlapping about 95% of their length. And then you have a constrained layer dampening adhesive in the middle. So first results. This would be the level of the driver if it were just radiating to the outside. And you can see the peaks can be pretty high in level of those primary panel resonances. So just an empty box with no bracing is here in red. Those primary panel resonances are obviously pretty bad. But when we add that single oak brace, and this is measuring at the rear, first thing to notice here is we didn't get a whole lot of change right here. I think because the rear panel is quite a bit narrower than the side panel, where we see much more of a difference, so it doesn't affect that low frequency region very much. But then you can see, you know, that dropped that a lot, did create kind of a new resonance there. But overall, you know, if you consider this as area under the curve as a difference in the energy, you know, this whole region is gone, and so that's great. This area up here is worse. But overall, you could have to say bracing was certainly helpful. It knocked down this rather ugly energy, and it did add a single new narrower peak there. So first lesson, bracing is not quite as straightforward as you imagine. It will shift the frequencies up some, and sometimes it considerably reduces the energy, and sometimes it just creates even higher peaks at a higher frequency. Okay, here is our side panel measurement, same box. First thing you notice is just the empty box with no brace is a pretty ugly situation. Yes, this primary panel resonance is about as loud as a driver that was radiating to the outside. That's how bad some of these resonances can be. That's why I think, you know, we have to do something for them, and I think you'll see it's not so obvious what that is. But on the side, which is a longer span, which makes it flexier, which makes it more susceptible to flexing in that low frequency simple pressure region, the first thing you can notice here is adding that brace really drops that level, right? So bracing for low frequencies is absolutely a no-brainer. It's doing a whole lot of benefit is happening right here. Now in the primary panel resonance region, you know, from here to say here, on the side panel, I mean, still you'd have to say this is a success. It's knocking down all this energy down to here. So that's awesome. That's a considerable amount of energy that's coming out. But here we see it created a new higher frequency peak, so not without its downsides when we're simply bracing. And the rest of the region really comes down. I like that, but then it bounces up and is actually higher than the empty unbraced box. Then we can see on average it's better in the mass controlled area to an extent. Okay, next sample is what's called matrix bracing. We have braces touching all sides, and then the center of those braces all connect to each other. So these are not separate braces for each pair of panels. And what are the results? I'm going to compare this against just the simple bracing we just went over. Okay, and what are the results? Well, the first thing to notice is the matrix brace really knocks down this lower frequency peak over just a simple dowel brace. Here, not, I would call it about even. You know, the peak of the matrix brace is a little bit lower than the dowel brace, but you also have a wider resonance overall. So I wouldn't consider that much of a win. Then in this region, the matrix brace is, you know, it's a bit lower. I like that than the dowel brace, so that's pretty decent. Going on to the side panel measurement. Here, results aren't quite as impressive. The matrix brace is kind of really keeping energy up in here over just the simple dowel brace. And our peak on the matrix brace is actually a little bit higher than our simple dowel brace. And this region is pretty much a draw, so not much to be gained there. So what do we see with the matrix bracing over the simple dowel brace? I don't know, not much. Side panel's worse. Rear panel's a little better. So I would call that about a wash. Okay, moving on to constrained layer dampening bracing. So what I did was I took the oak trim and used some adhesive in the middle, and then the shear motion between the two braces is what does the dampening. And this idea came from Earl Geddes, who said that using if we were just use a dampening material here where it attaches to the side panel, that compressional tension movement doesn't really absorb a lot of energy compared to a shear movement like this. So this was why in my first tests I did this sort of double brace glued together with the dampening material in a shear motion. And these are those results. First thing to note, for the adhesive, I tried two different ones. One is this Wycon 310M Flex Classic, and the other one is Sikaflex 292i. The reason I picked these, both of them are construction adhesives, and I think they're both MS polymers, but at least the Wycon is. And those sorts of polymers are meant to be construction adhesives that have vibration dampening characteristics. The Sikaflex 292 advertises that right in its description, and then the Wycon 310M Flex Classic is an MS polymer, and those are intended to do the same thing. I have links to where you can get the Wycon. In the United States, you have to get it from Canada. In Europe, it's freely available. And I would pick that one over the Sikaflex. You'll see the results are pretty close. Well, I mean, they're almost identical. But the Sikaflex is really thick, and it's just kind of tough to work with. And the Wycon is just like creamy butter. It's great to work with. So I suggest the Wycon over the Sikaflex easily. If you are in an area that doesn't have access to these, you want to get a construction adhesive that has a Shore A hardness of low 40s to high 30s, no higher than the low 40s. And this actually crosses out most construction adhesives, even a lot of silicone-based ones that you might think should have a lot of dampening. They'll have mid to high 40s for Shore A hardness, and we want to be in that lower area. So what do we see? Well, first of all, the red is just the oak brace, simple oak brace we just went over. And we can see with both of the CLD braces, we're knocking good 5 dB off those peaks. Low frequency area, basically identical. That's good. So at least we know that we're not giving up performance in one region to gain performance in another. And then above the primary panel resonances in this region, pretty much a wash. And I would even say the same thing here, although I would say on average the CLD braces are a little better. I'm not too concerned with this region. You know, the levels are low and going down rapidly, so that is too much of a concern to me. And of course, for a typical woofer crossed over at 2 or 3 kilohertz, they're just not going to energize that a whole lot. Moving on to the side panel. And here we can see the results are pretty much the same. Primary panel resonance, the highest one knocked down a solid 5 dB. That's great. And the lower one actually is up a little bit with the Sikaflex. The Wycon is pretty much the same. Low frequency behavior, still pretty much the same. And upper frequency behavior, still pretty much the same. So CLD bracing, no downside, and knocks the peaks down 5 dB. So that's pretty solid. Okay, next style of CLD bracing. Here I used VHB tape from 3M. This is a construction tape that's probably 2 millimeters thick of a soft, pliable material, and it's intended to damp vibration. And here are the results. I'm going to compare this directly against the Wycon, since that's the one to beat, in my opinion. And the results at the rear panel, I mean, they're basically identical in primary panel resonance region, and even a little bit worse than the Wycon, just above that, with no gain at the low frequencies and no gain at the high frequencies. So at the rear panel, Wycon's a little better. Side panel, so in this area I would probably give it to the VHBs just a squidge better. Right here, Wycon is maybe just a bit better, with nothing obvious, no obvious difference above or below this area. So I would say probably a wash as far as that goes. Now I did want to try using that VHB tape between the end of the brace and the panel that it's attached to, just to see if that did make a difference. It's kind of similar to what KEF is doing in their LS50 speakers, although they're using a full window brace style with the, some sort of material that looks or sounds a lot like VHB tape to me. So let's take a look at those results. So compared to just a simple dowel brace, this is pretty interesting. Right here, the VHB tape is really knocking the level down. On the other hand, it creates an even worse peak that's even wider than the dowel brace. Then in this region, VHB tape, KEF style, is working better than the dowel brace, and that's the same up here also. Going to the side panel. Kind of a reverse story almost. The simple dowel is a little better right here, and worse right there. And which of those is worse? Well, I mean, this is getting to be a high level, so That alone can make it more audible. On the other hand, this has got more of a spread frequency range, so there's more energy over a larger area of frequencies. So that might contribute to its audibility. I don't know. Neither of these impress me all that much. And then the VHB tape is even creating this higher frequency, which is a little concerning. So where does that take us? Well, I think there's a couple things we can take away from that. I think the idea that you can brace high enough to push the frequencies up to a range that is beyond the average woofer passband, I think we can see that that's not going to happen. You know, if you look at the unbraced box versus the simple oak braced box, the frequencies do shift up slightly, but it's just not a lot. And so I think that idea is it's just unproven that you can shift those frequencies up outside of the passband of a normal woofer. I think to actually change the frequencies, shift them that much, which you're talking at least 1,000 hertz to 2,000 hertz higher than what a typical box, you know, this size and geometry would be. Yeah, I think you have to just use a different material. You know, you'd have to use, you know, something like a granite, you know, or aluminum. You know, something like that. Is a fundamental change in the material is the only thing that's going to shift frequencies that much. And then the next idea that bracing doesn't bring that energy down at all and it just shifts them higher in frequency. I don't think that's really supported either. For the most part, you're going to drop the energy radiated a lot by bracing for most of the primary panel resonances and for sure at the low frequency simple pressure region. But it does create some higher new peaks that are an issue, and you haven't really completely solved it by, you know, solved the panel resonance issue by bracing. So I think it takes a little bit more than that. The other thing I think showed itself is constrained layer dampening in a shear motion. It works real well. It doesn't give up anything at the low frequencies and chops those primary panel resonances about 5 dB. So that's well worthwhile and it's easy to do. So where do I go from here? I think some caveats, you know, to some of this. I've only done the simple bracing and the matrix bracing. I have not done window pane style bracing where it, you know, is attached to all 4 panels and then some sort of crisscrossed material in the middle attaching that, you know, a window pane with just 4 cutouts in it. I still have to do that to see what that looks like. I suspect it could be better than the simple bracing. It wouldn't surprise me. But I will say that I don't think it's going to change the overall result as regards some of those common theories out there. You haven't changed the material. You might have changed how much surface area of the brace is in contact with the panels. But is that going to raise your primary panel resonances 1,000-2,000 hertz? I really doubt it. We'll see. I could be wrong. But I think from what we've seen so far, I doubt that that's going to happen. But I am curious how those window braces react, especially compared to the CLD. Maybe once you get that sort of bracing, you don't even really need the CLD, which would have to be the case if it's better because there's no way to do a CLD if you're using window pane braces. So I hope that was helpful to everybody, and I will see you in the next episode. We will be talking about the materials that you make the box out of itself, and that should be pretty interesting. All right? Thanks, guys.